class, welcome to the last video of the first section of Chapter 4. Okay, this is our last video before our chapter test. Alright, so we're going to warm up with a little problem like this. Hopefully we all agree. If I'm trying to fill in the blank here and this is multiplication, what am I going to have to do to solve this? Yeah, I'm going to have to do a little bit of division, okay? So let's see here. I would have to take 832 and I'd want to divide it by 13. And what I care more about here is the algorithm or the procedure that you're doing, okay? And I know this is just numbers, but we might be using this in a little bit. Because, excuse me, I need to look at this. This is a two-digit number. I need to figure out how many times it goes into the first two digits. So let's think here. 13 into 83. I'm thinking that's a 6. Alright, thinking that's a 6. What you do next, if you guys remember, is you multiply this. You need to figure out what's left over. So 6 times 13, 60 plus 18, 78. Alright, which leaves me with a 5. And then I bring down the 2, so I have 52. How many times does 13 go into 52? 4. 4 times 13 is 52. Remainder 0. We're done. We now know that our answer is 64. Now, long division. You might not have done that in a while. But again, I want you to understand procedurally what we did there. We took the two digits, we figured out how many times it went in, and then we found what was left over, and we just kept going through that algorithm or that procedure. So we're going to do something with that in a little bit. What we will jump into right now is some stuff on 4.3. So when we look at something like this and we want to find zeros of a polynomial, well, we have found zeros of a polynomial previously, right? Up until basically yesterday, though, when we were finding out how many zeros, we were always just talking about real zeros. And so what we said that because this is degree 4, because it's degree 4, well then real zeros is at most 4. Alright? But what we just learned in our last video is that now when I change from real to complex, there has to be exactly 4 zeros. What do we know about them? Some real and or some oh my gosh, I can't spell imaginary. Sorry. Alright, some real and or some imaginary. So, let's take a look at this problem up above, or this function I should say, 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18, and I know that I want to get some PRZs. Alright, PRZs, look at our constant, plus or minus 1, plus or minus 2, plus or minus 3, no 4, no 5. Okay, so we found the match, so now we're just writing the other matches. Alright, but there is a denominator, so we need the plus or minus 1, plus or minus 3, because those are my factors of the leading coefficient. And now I finish this by making a better list. 1, 2, 3, 6, 9, oh my gosh, 18, let's see here, 1/3, 2/3, oh thank goodness, I'm done. Alright, 3/3 is 1, 6/3 is 2, 9/3 is 3, and then 18/3 is 6, and I already have those, okay? So, there we go. There's our list. If we saw something like this, you guys know what you would have to do. You would need to start synthetically dividing. And again, we always suggest that you do what? You start at the left or the smaller numbers because they're easier, and you work your way up. Now, in this case, again, to save some time in this video, I'm going to skip a couple of them because I know it's not 1 or negative 1. I also know it's not 2. Please understand, on the test, especially because it's going to be shortened periods, we're not going to give you anything like super crazy where you're not going to find something until like 9, okay? It'll always be within like the first 3 or 4 probably, okay? So yes, I might need you to do some checking, but it shouldn't be like too much, all right? So I know that it's going to be -2, so we're going to skip just to kind of show you what's going on here. So 3, 5, 25, 45, -18. And let's see here, bring it down. I got a 3, a -6, a -1, a +2, a 27, a -54, a -9, and a +18. Alright, so I know my remainder, so I know I can rewrite this. Let's do it. F of x equals, be very careful, remember it's x plus 2, right? If I divided by -2, I get +2. And then I'm left with 3x cubed minus x squared plus 27x minus 9. And hopefully you guys see I can factor by grouping. Alright, so I'm going to do it. X plus 2. I'm going to go right to the end because I can also kind of do some of these in my head. Actually, wait, no. I'm going to confuse you guys. I'm going to not do that. Alright? I do not want to confuse you guys. Alright, so I know that I'm going to look at the first 2 and the last 2, and I know that I can take a what out of the excuse me, out of the first 2. I can take out an x squared, so I'm going to do it, which leaves me with 3x minus 1. And then what can I take out of the second 2? I can take out a +9, which leaves me with 3x minus 1. Alright, so now we know how this factors. X plus 2, 3x minus 1, x squared plus 9. Alright, this is f of x. What I want you to understand, guys, at this point in time, or up until basically yesterday, and even on that checkpoint that we took, I would have stopped right here. Why? Factor, and we know that we can't factor this over the reals. So you need to be able to recognize that if I tell you to factor over the reals, then you would stop here. This is factored over the reals, right? Because we know that this is going to be imaginary. What we're trying to say, though, is that we're trying to get this idea across, right? If we want real zeros, at most 4, there's our 2. But if we're talking complex now, or factoring over the complex number system, I need all 4 factors. Alright, and that's what we're going to work on now. Now in this case, this one's actually really nice. We could use quadratic formula because we have a quadratic, but this is also really nice because we can just use the square root method here, and we can say x squared plus 9 equals 0, or x squared equals -9, or when we square root both sides, we get x equals, now let's think about this, when we take the square root of anything, we're always going to get a plus or minus, and we know that because there's a negative underneath the radical, we're going to get an I at the end. What's going to go right here? Well, you're going to have once you take out the -1, you're just going to have the square root of 9, and that's 3. Alright? So, we can now actually continue to write this in a different factored form, and that's going to look like this. X plus 2, 3x minus 1. I had plus 3i, so I'm going to say x minus 3i, and then the -3i, which means I would have x plus 3i. Alright, and what I need you guys to understand is the difference between these two, right? This is factored over the complex numbers, and I'll just say that for now. Okay, this is factored over the complex numbers. So you have to be able to recognize the difference, and you have to be able to read a question and figure out what I want from you. Okay? So the last thing on this page is basically I want us to be able to state the complex zeros. Well, the complex zeros are all zeros, real or imaginary. Okay? So my real zeros should be x equals -2 and x equals 1/3, right? That's from right here. And then, of course, we have x equals plus 3i. I guess I didn't need that plus sign. Or x equals -3i. And that was from these two that I had over here. All right? Okay. We're going to move on to another problem. It's a little different. I'm giving you this example up at the top. It's a fourth degree polynomial. All right, fourth degree polynomial. I already know 1 0, and this is imaginary. So what does that mean? I also have its conjugate. So I actually have 2 zeros, and I'm looking for the other two. Now, this is kind of where that warm-up comes into play. I know that if I'm going to write f of x in factored form, it would have to have 1, 2, 3, 4 sets of parentheses. All right, 4 sets of parentheses. And what's really cool is I already know 2 of them. I know x plus 2i, I know x minus 2i, and then I don't know the rest, okay? But what I do know is that I can distribute this one out, I can distribute those two out, and I get just 2 pieces. All right? Now when I do x, when I take this term, or this factor, sorry, and multiply it by this factor, I'm going to get x squared. What's going to happen when I do insides and outsides? They're going to cancel. So over here, I'm just going to have a -4, but it's going to be -4i squared. And we know that I squared is -1. So what am I really going to do? I'm going to change my sign to positive. Now remember, this is still f of x equals this. Here's the problem, okay? I don't know what to put in here. What could I do to get this? Well, think back to the beginning. I had what? What was my number? A 13. I had a 13, and I was trying to figure out how to get to 832, or what to fill in, right? So I divided. Well, it's the same thing here. But Mr. Rabens, this isn't linear. And I say to you, you are correct. This is not linear. So we cannot use synthetic division. Okay? This is a situation where you cannot use synthetic division. And that is why I needed you to remember your long division procedures, or your long division algorithm. Because what we are going to do is we're going to take f of x. So right here, what do we have? 2x to the 4th plus 5x cubed plus 5x squared plus 20x minus 12, and we are going to divide it, sorry about that weird bar, by x squared plus 4. Okay? Hopefully this kind of rings a bell for some of you guys from Algebra 2. If not, I'm glad we're working on it. Now, basically what we're going to do, same thing as before, I need to figure out how many times this x squared can go into 2x to the 4th. And I know it's kind of weird and goofy with x's, so I actually think oppositely. I think, how do I get from x squared to 2x to the 4th? It's kind of just this, it's the same thing as the division, I'm just kind of working backwards. And I'm going to say, well, I need another x squared, and I need 2. So I'm going to say 2x squared. Now, if you remember the next step when you're doing long division with numbers, you basically multiply this by the values, right? And you rewrite it, and then you find what's left overs. Same thing here. I'm going to distribute this 2x squared to both of my terms, so I get 2x to the 4th. I don't get any x cubed, so I'm going to skip this, and I'm going to have 8x squared. All right? Now, the next thing you need to you got to remember this. Remember. You always have to subtract what you just got from the original. So I don't even like to think about it as subtraction. I just want you to remember you got to flip the signs. Because when I do that, see ya comes down, and then this becomes -3x squared. Now, I usually bring the rest down with it just to kind of see where I'm at, but it's, again, very procedural. I'm back to this. Now I'm figuring out how many times does x squared go into 5x cubed. Well, to get to 5x cubed, I need a 5 and one more x, so 5x. And now when I distribute, I get that 5x cubed, right? 5x times x squared is 5x cubed. 5x times 4 is 20x. So I'm going to put my 20x and line it up where it should be. I draw my bar, and again, I change the signs. Cancel. Ooh, cancel. So now I just have negative 3x squared minus 12. Let's see here. To get from x squared to negative 3x squared, I just need a negative 3. So negative 3, okay, negative 3x squared. Negative 3 times positive 4 is negative 12. I change my signs. Cancel, cancel. I'm at 0. And that should always happen, okay? This should always happen. So now I know that my quotient, or my answer to my division problem, is 2x squared plus 5x minus 3. So 2x squared plus 5x minus 3 goes in my answer. Things to keep in mind. Remainder will always be 0. And the reason we know that is because we're not guessing at zeros, right? We're not guessing to see if the remainder is 0. I already told you that we had zeros. Okay, so these are for sure zeros. You have to trust me on this because we have specific zeros already. Okay, so if you don't get a 0 here, you did something wrong. Now, last thing, now that we kind of have this problem up at the top, it says to write f of x in factored form. All right, write f of x in factored form. Well, we know that it's still going to be f of x. We already had two of our factors from the very beginning, right? X plus 2i, x minus 2i. So I'm going to write those. I need my other ones though, okay, my other ones. So what we have to do is we have to factor this, 2x squared plus 5x minus 3. All right, now I know it's going to have to be 2x and x. Sorry, I'm a little bit off the page, 2x and x. How do I get from that factors of negative 3 to that 5? Well, I think I'm going to have to do, what, plus 3 over here, because 2 times 3 is 6, and then take away 1x to get to 5x. All right, so now that we have it in factored form, we can say that our zeros are negative 2i, positive 2i, 1/2, and negative 3. All right. We are going to do one more of these. I hope this is making sense. I hope you're kind of at least understand conceptually what we're doing with this long division. We're going to do one more. But again, this, just think about it like the numbers, like that you used to do back in grade school. All right? All right. Let's take a look at this last example. Find the complex zeros of x to the fourth plus x squared minus 2x plus 6, right in factored form. All right. So we're basically doing the exact same thing that we just did on the last problem. It's giving us a hint. It's saying that none of the PRZs work. So if I made a list, 1, 2, 3, 6, they wouldn't work. What it's telling us is that very specifically we have a 1 plus I for a 0. All right, so f of x equals, if 1 plus I is a 0, that means that my factor from that is x minus 1 minus I. Okay, do we remember that? Remember that the zeros are always look opposite in their factor form. Okay, and then you have to remember that if 1 plus I is a 0, what else is 1 minus I? So x minus 1 plus I. And then we don't know the other two, right? We got some work to do for those. So this is that situation like yesterday, what we talked about, where I know it's kind of tough. I don't want you to just distribute and triple distribute 3 times. That's going to be really tough. It's going to get you a nasty answer. There's lots of room for error. I want you to remember that we can kind of look at the first 2 pieces as your A. You can look at the second 2 pieces as your B. And you can realize that this is just A minus B, A plus B. All right, A minus B, A plus B. And that's good. We like that. Because if it's A minus B times A plus B, it always expands to, do you guys remember? A squared, so my A piece squared, minus my B piece squared. All right, I still don't know that, but actually I'm going to just say I'm going to multiply them, so I just have 1 piece now. All right, so let's figure this out. What do we have? X squared minus 2x plus 1, and then minus I squared. That means I'm going to be subtracting a negative 1, or f of x equals x squared minus 2x plus 2. All right? Now remember, I want this. I want to figure this out. I know what f of x is from the original. I know what factor I currently have. This is a quadratic. So I can divide using long division. Why do I have to use long division? It's not linear, okay? I'm going to have to use long division to divide this quadratic out of this quartic. All right, so let's do it. All right, x to the 4th plus x. Ooh, shoot, I'm making a mistake. Guys, you gotta use placeholders in this. All right, you need to use your placeholders. So because there is no x cubed, I'm going to put plus 0x cubed. I don't know, at the end of the day, it would have worked without it, but it's just so much easier to understand what's going on and what lines up with what when you put in your placeholders, okay? So make sure you do that. And then now plus x squared minus 2x plus 6. All right, and we're dividing it by, ooh, this is ugly, sorry, x squared minus 2x plus 2. All right, hopefully you guys can see what I'm doing here. Real quick, just so we remember, and when you're studying, remember placeholders. All right. All right. So let's do this. Remember, how do I get from x squared to x to the 4th? That's x squared. X squared. So now what's the next step in the procedure? I multiply every single piece of my quadratic by this x squared. So I get x to the 4th minus 2x cubed and plus 2x squared. Now if you remember, what do? We need to subtract, or we need to change all the signs. So I'm going to subtract, add, and subtract. Okay? When I do that, I get a cancel, I get a 2x cubed, and I get a negative x squared. Then bring the rest down. And then I repeat. It's the same thing. How do I get from x squared to 2x cubed? What do? I multiply by negative, why not negative, sorry, positive 2x. All right, 2x times x squared is 2x cubed. Good. So now 2x cubed, then 2x times negative 2x is negative 4x squared, so minus 4x squared. 2x times positive 2 is positive 4x. And again, what do? We change our signs. Cancel. I now have positive 3x squared, negative 6x plus 6. And I hopefully recognize to get from x squared to 3x squared, I need to add 3, or multiply by positive 3, I should say. Okay, so 3x squared, 3 times negative 2 is negative 6x. Positive 3 times 2 is positive 6. Change all my signs. 0. Okay? I now know that when I divide my original function by this quadratic that I found, I get this quotient of x squared plus 2x plus 3. All right, now we're getting there. We're getting there, we're getting there, we're getting there. In the other problem, we were able to factor this. When we look at this and we try to factor, what factors of 3 add to negative 2? There aren't any, so you guys know what we do. You know that if you cannot factor a quadratic, we go to the quadratic formula. And let's do it now. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So we keep going. Negative 2 plus or minus, well, 4 times 3 is 12. 4 minus 12 is negative 8. All over 2. We got to clean it up. Got to keep going. Oop, I'm almost off the page. Okay, so negative 2 plus or minus. Let's see here. We know that we're going to pop out this negative 1, right? We know we want to take out the negative 1 from underneath the square root and make it imaginary. So an I. What's going to go here? Square root of 8. Well, we can definitely take out a 4, and then we would have 2 left over. Okay, so 2 root 2 I. This is still all over 2. If you use your heart method, we know that we have negative 2 plus or minus root 2 I. Those are our zeros. Okay, so what's really nice about this, when I write them out, negative 2 plus root 2i, negative 2 minus root 2i, we're getting really close to the end, guys. We're getting really, really close. These, okay, we got it. These are my two solutions from this second piece that I had, right? This piece right here. So what I'm going to do is I basically have to write this. It says to write it, find the zeros and write in factored form. So I already started to write in factored form. I just need to take my zeros that I just had, so this one, and put them into factored form. So you're going to subtract them, right? Let's go back to green. It's going to be an x, and then if you remember, it was negative 2, so I'm going to subtract negative 2 and make it plus 2. And then I had a positive root 2, so it's going to be negative root 2. I in this first one, and then the other one will be x plus 2 plus root 2i. And this right here is my answer to writing in factored form. I'm not going to rewrite it. That's factored form. The last thing we have to do, we have to get the rest of the zeros, okay? And actually, there's not that much work to do. You already, when we came down here, we already came up with 2 of them, right? Here are 2. And we already have the other ones, okay? That's the nice thing. You already have the other ones from the original, or we told you, right? One is 1 plus I. And then the other one, of course, has to be its conjugate, so 1 minus I. Alright, let me make sure that you can see that. Alright, 1 plus I, 1 minus I. Does this make sense now, hopefully, why the PRZs weren't going to work? Look at all of our solutions here. None of them are real. If we went to graph this polynomial, if I can get there, if we were going to go and graph this polynomial, it would not have any x-intercepts because all of the solutions are imaginary. Okay? Alright, so this was our last video. You now have every tool you need in order to complete the work, the classwork, and then also the assessment next week. Alright? I hope you guys have a great day. See you next time.